which are available over at Cal Copy. And you should get the Unix and Linux System Administration Handbook, so I'll be giving reading assignments for that as we do each of the various labs. And most of our exam questions are going to come from the labs themselves, the stuff that you've learned in the labs, but I will be picking some stuff out of the handbook as well in chapters where I told you to read up on these particular topics. Okay, because there's no way to say everything that needs to be said just in our lecture sessions that we have here, so you will have to do some outside reading. And again, remember, this is going to take quite a lot of time. We have 150 pages of lab work already set up, plus you're going to have some individual assignments over the semester. So you really don't want to be in this course unless you really have a good deal of time to devote to it this semester. All right, any questions since our last time? All right, well, I figured what we would do today is start looking at one of the labs, and I'll give you some sense about what those things are like, if you're still thinking about which electives you should be taking this semester or whatever. And that'll also prep us for being able to break up into groups, probably next week then, and actually start doing Lab 1. All right. So how many people were able to get the notes at this point? And no problems with doing that, right? All right, and again, if it turns out you do drop the course, but you've already bought the notes, I'll try to help them get hooked up with somebody who doesn't have them yet.
Today in the morning, they ran out.
Yeah, but they should be able to make up a new one in just a matter of minutes, right? If they have a long line or something and you just don't want to wait around, but otherwise you just wait there and they'll make one up for you. It's going to be hard to do this first week since they're so incredibly busy. Yeah.
I went 30 minutes ago and they just printed out some more. So they have
okay.
copies.
Excellent. Yeah, usually it's almost as fast when they do 5 copies as 1 copy, so they figure they're definitely not going to be left with some unsold ones, so run several at a time. All right, so after class you may be able to go over there and get it. All right, so thanks for the tip. Okay, all right, so as it suggests up here, we're not going to start with chapter 1, but the things relevant to what we're doing in lab 1 are chapters 2, 3, and 7 in the textbook. So that tells you a little bit about what it takes to be a super user on the system, and just other things that are related to what's going on in this lab. Okay, so next week I'm going to have a few DVDs burned, essentially, for you to be able to put things up on there. And if we're lucky, maybe I'll even have a USB drive, which is going to go faster than the DVD. And, there's like 8 machines, I think, in that room, but I'm not going to have 8 different DVDs because there's no room for all of us to fit into that little half a lab that we've got at the same time. So presumably different people will be coming at different times of the week to do this. But we need to do the first 40 steps or so of this lab as a group. So it will be a shared experience. And in general, as you're doing these, try not to leave anybody behind. Some people may still be reading and not quite understanding what's going on. So your job at that point is to be a bit of a tutor and help them get up to speed with what's happening and why it's happening. All right, so what we have on the machines right now is one big partition, well, actually several partitions, but they're all used by Windows 7, I think, is what I've got on most of them at the moment. So when we try to do this install, it's going to shrink one of those partitions down, and we're going to shrink it down quite drastically because we're never going to use Windows this semester, and instead make some room for Mint 17.2. All right, so with the machines that we have here, if you do just press their on-off button, that suggests to the operating system that it should shut down. And Windows and Linux, etc., do know how to do that. Some of the older operating systems don't really know how to make that sort of thing happen, and you really would just cut the power and maybe screw up the disk drives a little bit. When you have a mounted file system, there are various data structures and stuff that are not really the way they're supposed to look like when you first boot up the machine. And so power gets cut off unexpectedly you have some inconsistencies with those data structures. So we generally don't want to just pull a plug on something. That means there needs to be some repairs happening before you can boot up again. Now, back in the 80s, this was really kind of a very hard thing to do. You had to look at every single node on the entire operating system and rationalize everything and find out what might have gone wrong. Nowadays, these things go much, much faster because we do what's called journaling file systems. Before we touch anything on the disk drive there, we make a little note of what we're about to do, and you go ahead and do it, and then you can erase that note as having it been completely done. Okay? And that way, if there is a power failure, you just look at this log of things that have been happening here, and you see what's still supposedly being done, and now you know exactly where there might be a problem. And you fix up those one or two little problems rather than looking at the whole disk. And if you have a 5 terabyte disk, that would take quite a long time to do. And then you can fix things fairly easily, and so those sort of power failures usually can be fixed rather easily. Right? Any damage that was done in a power failure can be fixed fairly easily. Now, back in the 80s or so, with what was the equivalent of Rohan back then, which did crash quite a bit at the time. If they did have something like that, checking the file systems on what were, in those days, still relatively small disks, it could take almost an hour before it was back up again. But here it should just be a matter of minutes if we do run into those sorts of problems. So we shouldn't have to just pull the plug on these systems, even though you don't know how to log on to one of these Windows machines, assuming they require passwords or whatever. If we just push that little button there, it will do a graceful shutdown and not mess up their disk drive. Right? Now, Mint is not going to want to try to shrink a Windows partition if it's a damaged Windows partition. Right? It wouldn't really know how to do that, and perhaps would not do it correctly under those circumstances. Right? So it is important to get things shut down well, otherwise you won't actually be able to do the install. We'd have to bring up Windows again, let Windows fix things, and then shut it down more gracefully so that we can do that. Right? We don't want to be moving around broken data structures. They're just going to get even more broken if you were to do that. All right. Now, one of the things you should get in a habit of doing as a system administrator, and this will be fairly easy to do when you're in a group. One of the people in your group should be the designated typist for a while at any rate. Somebody else should be the one who looks over their shoulder and makes sure they're typing the right things. Right? Because just putting an extra space into a command or something can really mess stuff up. Right? You could do things like, let's say we're going to do an RM with a wild card in there. Right? You could say, remove everything that begins with an A star. Right? So that would get rid of, in the current directory, all the files that start with an A. On the other hand, RM A space star will get rid of a file called A, a one-letter file called A, and then get rid of absolutely everything else in that directory. And it gets worse. There are other options for RM, the -RF option that says recursively get rid of things. If you find a directory, go down in that directory and get rid of everything in there too, and so on down the line. So there are horror stories of people basically wiping the entire file system because of one character being mistyped. Okay? So you probably won't do anything quite that drastic if you mistype things, but things kind of go down the rabbit hole there, and what I'm telling you is supposed to happen next in the lab isn't happening because the previous command didn't do quite what it was supposed to do. So having one of your folks being the designated spelling checker is probably a good thing. And somebody else can be mouse boy or something for these things. Okay. And somebody else can keep track of just what step you are in the lab, so you make sure you don't skip one or do something twice or whatever. Okay, so this is really going to be your main learning experience where you get stuff, in part because I'm going to be talking about them a lot in class as we go along, so you're pretty much prepared for the labs. And we've taken, as I mentioned last time, various detours in here, things you don't really have to do, but it's a good way for me to talk about how things actually work. Right? And so we'll do some things that aren't particularly necessary or might even not work. You know they're not going to work, but I want you to see how things don't work so that you're not surprised in the future when you say, oh, I've seen that before. Okay, and in general, our exam questions are going to be, why do we do this particular thing? So essentially, you want to know what you're doing as you're going along here. Why are we doing all these various things? And with a group of 4 or 5 people, you probably can get an answer that you all kind of agree on. And if not, that's a good thing to ask me either in class or by email later on. So if you pay attention to these things, you should be fairly well prepared for the many of the questions that are on the exam. Okay. All right, so somewhere in the room there's going to be some DVDs or USB stick, etc. for you to use. I'll probably put them in little containers and label them. But you may have to go around and look on the disk drives of some of the other machines if somebody forgot to put them back where they had been. Okay. Our lab, by the way, I'm not sure where it says this in the notes, is going to be in 408C essentially, which is again very close to the math department office. If you've gone to the bits and bytes things, it's basically right across the hall from there. All right, so that's where our machines are going to live this particular semester. And our, actually I don't even really need this board. These things are pretty white without it. Our setup here to sort of protect you from the rest of the universe, and perhaps more importantly, protect the rest of the universe from you new system administrators here. We do have, the internet itself. Right, and there's a main gateway of 130.191.1.1 that feeds into the university. Right, and from there, if you do a trace route on something, you go to places like Rohan, or what's going to be Rohan's replacement, Eris, right, and Legolas is a machine that's in this lab here. And then that guy has 2 Ethernet interfaces on it. One of them, which connects to the rest of the internet. Actually, there's a big ring around here, a big backbone within the campus, so we don't go directly from there. But then there's a second Ethernet card here, and this guy goes to our various hosts, which will be Bilbo and Frodo and company. And so you're going to be assigned to one of those little hosts there. So to get anywhere, you're going to have to get to the outside world, you have to hop through Legolas and then go your merry way from there. Right? But from the outside world, if you try to SSH to Legolas, that doesn't work. There's only a very few machines that you can get to from the outside world, like Rohan and Eris and mail.sdsu and our various web servers and cs.sdsu.edu, that's really virtual machine now at this point here. And the machine in my office actually can be seen from the outside world as well. But there aren't all that many outside contacts, because that way we don't have to worry so much about security. As long as you have security at the border and not too many border entry points, then life is a little bit easier. Okay. All right, so we're going to, once you find the DVD or USB stick that you're going to use, we'll shut down the machine you've been assigned, so you need to make sure you go to the machine which has the correct label on it. Right? If you blow up somebody else's work who've already put up lab 1, well, you're going to be responsible for putting it back and then going to the machine you were supposed to do your own work on. Okay. All right, so what we're going to do to be able to not boot into Windows the next time on here, once it's actually off, turn it back on, and on this particular hardware, it's F12 that you use to get a little menu here to say what you want to boot from. Their default is to just always boot from the hard drive, and that would get us back into Windows at the moment. Later on, it's going to get us into MIT from the hard drive, but not right now. So we have to tell it to do something different, and you'll tell it to, boot from the DVD drive, or if you've got this magic USB stick, you can boot from that instead. Right, along the way in the labs, there's, I have these little symbols out here when there's something I particularly want to warn you about. Right. And one of the things, you can get partway through this lab and then things just stop working if you don't make the right choice right at this point here. So, whether you choose when you're putting up a Mint system here, Legacy or EUFI, really does depend on your hardware. And in this case, we have to choose the right thing, otherwise things stop working later on. Right? So there was an old way of doing boots and so on, and now there's a newer way, and you'll learn a bit more about this in the operating systems course. But it used to be the BIOS, the basic input-output system here, that would have initially come on here and do a post thing, power on, setup and test for that. And now they have a fancier way of doing things with a lot more capabilities. This EUFI system that most of the stuff that's being sold these days are using are pretty amazing. Even with no operating system installed, you can, under the right circumstances, as long as the machine is turned on, come in over the network and get in there and start doing things with it, with this system, even if you haven't yet installed any operating system on the whole thing. Now, of course, once an operating system does start booting, they turn off that feature because that's a huge security hole otherwise. But on a blank system, it is a way to get in without even being in front of the hardware itself. Okay. All right, so again, this varies system by system. Again, if you're going to do these things on your own system at home, you probably shouldn't follow these directions verbatim. So where things might vary, I'm trying to explain that out here. By the way, last time I might have given the impression that you have to do some stuff on your own system to pass this course. That's not true. Everything we're going to do is basically on those lab machines and on Rohan, and maybe on Edoras a little bit later as well, although I haven't written anything up for that one yet. But a good way to solidify what's actually been going on in the labs is to do similar things with some of your own hardware. And you can pick a really old desktop or laptop that you have, as long as it's still running, and Mint will run just fine on that. It's not a pig as far as needing resources goes. Now, you won't be able to play the latest games and stuff on it if you've got really old hardware. But to do the sort of things we're trying to do in the lab, any old hardware would work just fine. If you've got an old laptop laying around, that's a good place to start. And eventually you can convince maybe I want to do that on my current laptop too. All right, so how you get into the BIOS or affect the system like we're talking about here, it's not always F12. Often it's an F2 key that would do it. Sometimes it's F10. Sometimes it's escape. Sometimes it's the delete key even that does it. So it varies by system. And often in the startup screen, they'll give you a little hint as to what you're supposed to press if you want to go into setup, essentially. All right, so for us, F2 doesn't do what we want. It's basically a self-test mode, and it's going to check out all the memory by reading and writing bits to that to make sure that the memory, your RAM is working the way it's supposed to. All right, so for us, F12 turns out to be our option. So also a little bit of experimentation would do that if you can't find it in the document somewhere. Okay. All right, so as far as dealing with the DVD here, one says you can try to bring this up with a legacy system. The other one would say you can boot the DVD using the EUFI system, Unified Extensible Firmware Interface. And for things to work for us, you got to pick that EUFI one. Now, on my laptop at home, well, the laptop I brought in here last time, I had to do exactly the opposite. I had to use legacy. It didn't like the EUFI version. Okay. All right, so what we found on this particular hardware, if you have put a USB stick in, and it happens to be a bootable stick, it prefers that over the hard drive. So you may not even have to do that if you're using the USB stick. And again, that's going to vary by hardware as to what its booting order and stuff is. So it used to be in the old BIOS system, you could go into the setup menu and choose a particular order, and it would try your floppy drive first, then it would try the DVD, and then it would try the hard drive as a default. Here, they just sort of always go for one thing, typically the hard drive, and you hit a special key if you wanted to occasionally do something else. Okay. All right, so even if you're doing the USB install there, again, bring this thing up so that you get the two options just to make sure you don't get the wrong option. And you may get a little error message here. I'm not quite sure I tracked down when this happens and when it doesn't happen, but it's never seemed to get us into trouble, so it's one of those things you can sort of ignore. Now, since we're starting a new install, it doesn't make sense to do an upgrade or something at that point for Mint, because Mint isn't on there anymore. But if what you had been trying to do was an upgrade, you would have gotten into your Unix system, become a super user, and tell it to shut down the system. Although with most systems these days, if you just push the button briefly, it really does initiate the same sort of a shutdown that you're getting there. Okay. All right, so you should get a little Mint logo coming up fairly soon here as it's starting to do its thing. And it'll give you a little menu where you have different options of what to do. And one of them is going to be the default. So you can sort of put a DVD drive in and walk away. And as long as what you want is the default, you don't have to be sitting there waiting to hit the keyboard. Right? Their default turns out to be the Start Linux menu. Right? So if you press any key, you don't have to even wait the 10 seconds. It'll just do what we want it to do. But you can use the arrow keys to go up and down and have it do things like an integrity check to make sure you burned that DVD correctly. Because if we have some bits wrong on that DVD, then some piece of software is going to get installed badly, and that could be a problem. So if it's a new medium, then you probably want to do the integrity check. I should have done this, don't have the disc down in the room yet, but I'll try to do that ahead of time, so you should be able to skip that part. But if you are burning your own disc, then definitely it's worth waiting a minute or two while it does that check. Now, there are other things you can do. Even if the DVD drive in there, you can tell, hey, go ahead and boot Windows again, boot whatever was on the hard disk. Now, as it turns out, when I tried that doesn't quite work. So to get anywhere later on, you're going to have to remove that USB stick. Otherwise, you're going to get this option, and then that particular version of the option is not going to work out for you. But if you just got the DVD thing in there, it doesn't hurt to leave it in, although when you're done with it, you really do want to put it back so that other people can get to it. All right, so fairly soon you will get an actual desktop and things coming up. And depending on the resolution of your screen here, it might look a little bit differently. We have pretty decent monitors in there, although they're not super large, but it's good enough for our purposes. Okay. Now, kind of like where the Start menu used to be under Windows there, you can bring up a little screen with different choices, and one of them is to bring up a little terminal window. Kind of like what you get when you use SSH going over, to Rohan. Right? And from there, you can get a root shell essentially out of that. The sudo command here, su is a switch user here, and switch user with no options on there means become super user. And so often you would say sudo, and then give it one command that you want it to run. But then that means if you have another thing you need to do as super user, you have to say sudo again and give it yet another command. Right? So a better thing to do is say, hey, give me a root shell to begin with. Let's run the bash shell. And give me all the root privileges, and then everything you type in that shell window then is going to be done with the authority of root. All right, so at that point you could fix things up if you needed to, and we'll talk about in Lab 2, I believe, what to do when your system won't boot and how you go in there and try to fix it, change some things, what to look for. So we'll get some experience with that. Even though our system isn't broken, we'll see what happens. We'll simulate doing some of the things of a broken system, just so we have that experience as well. Otherwise, what do you do? Start all the labs over again. We need to know how to be able to fix things instead. All right. All right, so among the things they do here is to make sure you don't have a bogus DVD here. You may have downloaded this from the internet from some suspicious site, and they put various malware and stuff in there that they're going to secretly install. They can do a checksum on this, look at all the bit patterns there, and come up with this big long string of numbers. And it's very hard for somebody to make some changes without getting a different string of numbers out of that. So on the Mint website, they can say what their appropriate string of numbers are supposed to look like to make sure you've got a real, genuine disk out of that. Yes?
I know there's a couple different flavors of mint as well. Are we using cinnamon or peppermint?
Well, we're doing the Mint version of Mint. So there is, yeah, I guess I should talk a little bit about why we chose a Mint to begin with. It's based on Ubuntu, essentially, which used to be the most popular thing, but then Ubuntu went from GNOME 2 and shoved GNOME 3 down everybody's throats, which was a really hard interface, essentially. It's great for a phone, and they wanted to make your computer look like your phone, where you run one application at a time. So it was hard to bring up more than one window, etc. There's a famous rant from Linus Torvalds, Linus as in Linux, operating system here, about what an awful thing GNOME 3 is. So what the Mint folks did was take basically most of Ubuntu, but basically stick with GNOME 2. They call it Mate, or it's actually Mate is the word, but it's M-A-T-E is how you spell it, so I'm going to wind up saying Mate all the time here. All right, they also have a Cinnamon interface, which is more similar to the GNOME 3 version. But we're going with Mate because GNOME 2 really was a very, very nice way of doing things. As you'll see as we configure each of your systems here, you'll have a rather nice interface when you get done with all this. So that's essentially why I chose Linux Mint for this. Now, an interesting thing, more recently there was a team that got together and they wanted to put the Mate desktop back onto Ubuntu, and now Ubuntu offers that as an option, because Ubuntu went from #1 down to, I think they're #3 or something at this point, and the #1 Linux operating system is Mint, mostly because I think they've got this Mate interface here that wasn't offered by anybody else. So Ubuntu's trying to make a comeback by imitating the Mint people. Okay. All right, I think that was the end of that digression. So that's way more of an answer than you wanted, but there you go. That's what happens when you ask questions. But everyone is quite welcome. Welcome all questions that come in. Okay. All right. We already talked about what happens with the disk sum and so on. Okay. All right, so if you do decide to check, it'll tell you, oh, I looked at this module, looked at that module, and all these guys presumably turn out to be okay. All right, so always a good thing to do if you've got a new disk that someone hasn't tried and not had it blow up in their face yet. All right. All right, so if we do that check and then we'll start over again, then you have to do this thing a second time. Again, whether you want to take the time to take this detour or not, probably going to leave up to you. All right, so start your system again after it's done with the check and do the Linux Mint thing here, and now you will get a full interface coming up. So one of the choices that you'll have, there won't be very much on your desktop here, but one of them on a little icon here that looks like a CD drive. Or CD itself. You click on that to do the installation program, and a big old screen will come up to get you started. All right, so you should have an active mouse essentially at this point, but you don't really need the mouse. Right? So there is you'll get a little window coming up, and it lists various languages, and you can use the up and down arrows to move to different languages, but the default is English, and that's essentially what we want. U.S. English rather than British English and so on. All right. Now, tab keys, if you have several different buttons along the way, you can use tab to move from one to the other. So among the things you could do here, you're initially in that scrolling menu. But if you hit tab, you'll go to the next button, hit tab again, you'll go to the next button, and eventually it'll cycle back up to the top. You can cycle in the opposite direction with holding down the shift key and hitting tab. So you can go back and forth between the two buttons quite easily. Or you can just click with the mouse. All right, so you want to get to where continue is highlighted here. You can use tabs to get over to that, or click it with the mouse. All right, so we can accept English as the default. All right, so next we're going to do a few sanity checks here. Do you have enough disk space to even install the operating system, let alone have some room to do some other stuff with it? And can we get out on the internet? Because we have to upgrade some packages later on. Now, if you don't have enough space, well, that's pretty much a showstopper right there. It won't proceed. If you can't get to the internet, it will let you do the install now, but you're not going to be really have a current system until you can go and download some packages and so on. But there shouldn't be any problem in the labs. You should get check marks for all of these items here. And if not, we want to find out where a cable is loose or whatever before you continue. Otherwise, things aren't going to look the way I'm saying they are later on. Okay, now last fall we had at least 2 groups that wound up blowing away the Windows partition completely. So make sure you do this next part right. We do want to keep that around. It's much easier for me to just re-expand a Windows partition the next time I teach the course rather than having to install the whole dang thing over from scratch again. Plus some of the other steps where we want to mount the Windows partitions aren't going to work if you've blown them away. Okay. All right, so depending on what you've seen on it is found on the hard drive here, it will give you various options here. Now, if I've screwed up and there's still a Linux Mint distribution on there, it may say, hey, I can just try to update this system that I've already found that looks like it's Linux Mint. Or if it finds something like Windows, which it should in this case here, it could say, okay, you can keep Windows and we can put Mint on there at the same time. We'll have a dual boot system out of this by shrinking down the Windows partition to make room for a whole new partition for Mint. All right, so the choice should not be blow away Windows, right, but instead install Linux Mint alongside it. Right, so don't do anything else if you can't get that option coming up. It's time to run crying to me at that point, or the lab assistants that we have in there. All right, so you'll get a new screen up here, and it'll sort of say what's going on with the disk drive. It'll represent the whole disk drive with a bar graph, and typically there's a partition 1 here that's used for booting, and it's typically a FAT file system, if I remember correctly here. And then it's used almost all of the drive for Windows 7. And then it has its backup stuff over here on partition number 3. And what it will propose to do is shrink this down. It'll typically take this thing and cut it in half, shrink down the Windows partition to that part, and put Mint over on this side. So this will wind up going to be partition 5, essentially. What it's going to do now is create a extended partition, and then you can create a bunch of other partitions inside of that. The old IDE drives, you can only create 4 partitions to begin with, and that made plenty of sense when we had really, really tiny drives back in the day. But soon disk drives got big enough where it made sense to have more than 4 partitions. So you can take one of the 4 slots that you have and make it basically a box in which to put another 12 or so partitions. So I think you can get up to 18 different or 16 different partitions on this thing. So this is going to be how the 4th partition is used, and then it's going to wind up putting Mint in most of that for what's called SDA 5 partition is where we're going to put most of the operating systems. But we're also going to create a second one here for swap space. And that's going to be SDA 6, if I remember correctly. All right, now it's going to offer to give you basically as much room for Windows as you have for Mint, but we're never going to use this thing, so we're going to try to shrink this one down. Now it's going to have, I think, a yellow portion here of actual used space, and then a white portion of extra space that hasn't been used yet. And we're going to shrink that down so that we have almost no other space left for it. All right. So assuming everything has gone to plan, there's going to be a little install now button that you can click, and at that point then it's going to ask you, hey, are you really sure about doing this? And then it really will start changing the disk drives and so on. So make sure that you've got things right before you get to that stage. Okay, Now, it's still going to need some more information, but may as well start setting up the partitions and shrinking windows and stuff while it gathers that other information for you. On other installations, flavors of Linux and they operating systems here, they get everything to begin with before they start doing anything. So it was kind of looked nice that they split it up this way, because otherwise you're just sitting around waiting for other things to happen. Okay. All right. So tell it yes. I really do want to continue. All right. So at that point, it's going to be taking a whole bunch of files that are compressed on that DVD thing and sticking them in their proper place on the system. So it'll first make a few partitions here. Right? It's sort of like think of this as a parking garage, and nobody's even laid down the white stripes yet. So first it comes in and formats that partition so that we know where the blocks and stuff are, and then it starts putting the files into that newly created file system. So that's what would happen next with that. Okay. All right, so as I mentioned last time, a good thing to do if you've got a little extra money to spend here and we're going to try to put Linux Mint on your current laptop that you're using and you really don't want to be broken, buying a new, say, solid-state drive, stick that in your laptop there and just install Mint on that while your other drive that you had been using is sitting on a shelf somewhere, and so you can't mess it up. And if something goes wrong, well, you can just put your old drive back in and you haven't lost anything other than a few hours of gain some experience. But more than likely, that will work out okay. And now you can, by one of those little connectors there, you can connect up a second drive to your laptop or desktop or whatever, and copy over whatever files and things that you need, and get it set up so you can even boot your old file system. Although we'll see better ways to do that as we go on in the semester. Okay, all right, so that stuff that I said last time and just repeated here is what this little part is about. It's a way to safely make some changes to your system. All right, so while it's doing all that stuff to this drive and copying all these files over, now it has more questions to ask you. So it's going to ask where the heck you are, and I think the default is New York City or something like that. But you want to pick basically USA Pacific, and so you pick basically the Los Angeles area. Got to go far enough north, because otherwise you get Tijuana, and they do different things with daylight savings time and stuff like that. So make sure you get US Pacific rather than Tijuana time. All right, so you have a choice about what kind of a clock to use here. And Universal Coordinated Time here, Greenwich Mean Time essentially, is what we're going to go with. Right? A worldwide time based on the prime meridian, which was in the middle of England. They got to make this choice because they were the ones that colonized a large portion of the world. And that way all of their different colonies and whatever could have a common time to work with. Okay? Now that's not what Windows does. Windows typically uses local time, or at least they did. I'm not sure what Windows 10 does these days. Whereas what we do here is we just pick universal time, and then you tell it which time zone you're actually in. And so it'll take whatever that time is and subtract 8 hours from it, because that's how far away we are from Greenwich Mean Time. Or sometimes it's 9 hours, depending on whether we're under the daylight savings time or not. But it'll make those sort of adjustments. Now, by the way, on your laptop or whatever, it can be a little bit tricky here. One of your two systems could easily be, 8 hours off from the other one, depending on what your internal timekeeping does. So sometimes, if you're trying to make this thing live comfortably within with a Windows system side by side on it, you would choose, just local time rather than daylight savings time. In our case, we don't care about the Windows 7 at all, so we don't mind if it's all screwed up. Now, we are going to get very, very accurate time on these systems here, because one of the things Unix systems do, assuming you set it up correctly, is to go out to some of the atomic clocks out on the internet there and find out what time it is and make adjustments to your clock to match that time. So each time you boot up, it will try to make those adjustments. And it does it in a really cool way. If you're off by 5 minutes, it doesn't just take your clock and advance it or subtract 5 minutes. It's going to have the seconds get slightly longer for a while or slightly shorter for a while until it gets in sync with what the atomic clock's on. Right? Because otherwise you have, oh, here's a file that just got created 3 minutes in the future. What the heck does that mean? Right? It does it in a nice, simple way for that. Okay? So normally when the system is running, the time is very, very accurate here. It's only if you've had it off for a while, right? There's a little button battery essentially on each motherboard or somewhere within your laptop here that keeps that little clock going essentially. And then that can get off by a second or two after a while. Right? Next time you boot up, doesn't have quite the right time, but Linux will go out and find out what the right time is and then slowly make some adjustments for you so you're back totally in sync. Usually you can believe the time set on a Linux system to a great deal of accuracy, less than a second. Okay. All right, so now it's going to ask, who are you? And we're going to create a generic name here that everybody's going to know about for a while. Each of the system is going to use a Lucy user. And back when we started this with SUSE Linux, it'll then suggest what the name is. And unfortunately, it doesn't give us a very good suggestion in this case, but it used to give you the suggestion of a loser. And we're going to have to put that in ourselves here rather than accept that default. All right. So this will be an account that we'll keep around for maybe 3 or 4 labs, and then we'll get rid of it because it's a security hole. Everyone in the class knows this, and they're also all going to know exactly what the password is, which is a really dumb password, right? We're going to just put in testing as the password on every one of these machines here. And it'll tell you that that's really not a smart choice. No word that's in the dictionary should you want to use there. No word in the dictionary with 0 or 1 on the end are good choices either. So it tries to see whether you've made a rational choice, but you're the boss, so you can say, yes, I really want this stupid password for here. Okay. All right, now, if you have a printed versions of things, it's usually a little bit hard to mess with, so this is probably not a great name to use, because maybe this is a 1 here rather than an L. Right? In some typefaces you can't quite tell. If it's electronic, you can search for an L or search for a 1 and figure out what it really is. But it's, or cut and paste a name on a screen here. But for written things, it's a little bit tricky. When I hand out Rohan passwords, you'll find that it's maybe a little hard to tell whether your password has an O in it or a 0 in it. And similarly, whether you've got a 1 or an L. So if you're creating random passwords, those are 4 characters that are good to avoid, because if you're a system administrator, you have people come to you saying, my password doesn't work, and they're just interpreting these characters incorrectly. So just don't give them those characters ever, and then that isn't quite an issue. So on Rohan, I think they do avoid the 1s and the L's from looking at my password list that I had gotten, but they do have some O's and 0s in there. Okay. All right, now it is possible to encrypt your home folder here so that even if your laptop falls into the wrong hands, they can't figure out what your password is to get to the data. It's just a bunch of gibberish as far as they're concerned. We're not going to do that, of course, for various reasons here. Because then everybody would need to know this each time you start up, etc. And we couldn't really put the machine automatically on there. Okay, so we want both of these guys unchecked. On your home laptop, you're probably the only user there, and it makes sense when the thing comes up to just go ahead and log you in as you. Right? But we have probably 4 or 5 different people who are going to log on this. 6 if you count me, 7 if you count or 8 if you count our administrators. And so we don't want a common choice for that. So those guys should be unchecked. But the second box, I forget what's in there, is one that should be checked. All right, so in Nemeth they talk about reasonable ways to pick passwords and so on, and each of you will have your own individual password that you're going to make for your account, but you also need to have a super user password somewhere in there. And as a group, you should decide on what that's going to be. All right, So look up good password choices in the book. Hopefully at least one of the people in your group has already got the book at that point, and you can argue about what that is, but try to avoid violence in your final decision. Okay. Now, as it turns out, on some Linux systems, like SUSE, for example, you really do need to know that root password a lot. If you want to do something as a super user, you need to enter the root's password. On many Linux systems, though, that's not how it works. We designate a few people as being capable of using the super user commands, and then the system is only going to ask them for their own password, not for root's password. So for Linux Mint here, we're not going to wind up using that password very much, but we will use it on the later labs when we do SUSE. Okay. All right, so on your bottom taskbar of this thing that comes up at this point, they have a few common things you can bring up there, like a browser and so on. But one of them is a little black icon, and it has something which looks like the prompt. Right? So on some shells, you use a greater than sign as a prompt, and that's the blinking cursor part of that. So that's how they show you you've got a terminal. You can bring that thing up while the installation is running. You can run many, many processes at once on here. And when you bring up that little terminal, you can do this little sudo bash thing there to get a root shell. And you can watch a little bit of what's going on. Now that we've answered their questions, they're still chugging away and installing things. We can run the top command here, and this will tell you what the processes that are using up the most CPU time and stuff are doing right now. So you'll see names of various processes there, and the things in that list will shift, every second or so, depending on who now is using the CPU most, etc. And so you can see a little bit about what's going on here. Right? If we had done this early enough on, we'd have seen it do the make file system command and do it various copy commands and so on. But at this point, it's probably running just packages. But you get to see a little bit about what's actually happening, get some clue.